Okay, folks, here we go. Last night we talked about similar triangles, how to prove them similar. Tonight we're going to talk about when we split our similar triangles into different parts. So the way that we do that is with special kinds of segments in triangles. The first one is the altitude. An altitude is a line through the vertex of a triangle, so through the point of any of the angles of the triangle to the opposite side so that it is perpendicular, meaning that it crosses the opposite side at a 90-degree angle. The altitude can be a side of your right triangle if it's a right triangle itself. The altitude can be inside your triangle, or in a case like this, the altitude could potentially be on the outside of a triangle. Um, the biggest thing is that it has to go through one vertex and it has to be perpendicular to the opposite side. When we have an altitude, then the altitude is proportional at the same rate as the sides are proportional. So for example, the relationship between 16 and 20 is going to be exactly the same as the ratio between x and 15. So I can always solve for any of these values by creating a proportion, cross multiplying, and then solving for x. Similarly, if we have an angle bisector in two similar triangles, then the corresponding angle bisectors are proportional to the corresponding sides. So again, I can set up a proportion. X over 15 is the same thing as 8 over 12, keeping in mind that if I put my sides on the bottom, 15 and 12, then I have to keep my median, angle bisector or my altitudes on the top. Okay. A median is another special line segment that goes through the vertex of a triangle to the opposite side such that it bisects that opposite side. So you create two congruent halves of the opposite side of your triangle, and these are also corresponding and proportional in similar triangles. So once I have a median, I can create a proportion with that over the opposite side. Similarly, I can set up the ratio here of 9, which is the length of my median in the second triangle, over 3, the corresponding length in that triangle, cross multiply and solve. Then finally, we have the triangle angle bisector theorem, which just says that if we have a line in any triangle that bisects an angle of that triangle, then where it intersects the opposite side is going to be proportional to the side lengths of the non-intersected sides. So basically, this and this are proportional to this and this. So really, you're kind of just making a fraction out of one side of your triangle and setting it equal to the fraction of your other side of your triangle. So we have 4 over x equals 6 over 13. And that's the triangle angle bisector theorem. So these are the 4 concepts that we're going to be talking about in class and doing some practice with. Let me know if you guys have any questions, and I'll see you then.